This is the start of data collection for the solid and liquid densities lab in CHEM 102. And here we have an unknown piece of wood, a geometric solid, and we can determine its volume by measuring the 3 dimensions of the block of wood. You can see here they sort of are. Whoops, there we are. So let me make some measurements or position and I'm going to line up that start point with the edge, so it just sort of bisects, and you should estimate the length to a 100th of a centimeter. So don't choose the closest millimeter marking, but estimate where it is in between. Now we're going to measure the mass of the geometric piece of wood. So first I'm going to turn on the balance. Wait for it to tear, or wait for it to zero. I'm going to take this little piece of weighing paper to just protect the system, and I'm going to zero it, and then I'm going to put the piece of wood on the pan, and let me show you the value that we get. In the next parts of the experiment, we're going to be using a 25 milliliter flask with a ground glass stopper. This is ground glass, and that makes a nice tight seal. And we're going to, it's not exactly 25 milliliters. It's very close, but we need to calibrate this flask. And so we're going to fill this up with water, and using the known density of water, determine its volume. But first we have to make sure it is dry and clean. So first I'm going to put some acetone in here, just a little bit of acetone. And acetone is helpful because it dissolves, it mixes well with water. And so I'm going to go dump this out into a waste container, and that'll carry any water away. And it also has the advantage that it will evaporate very quickly. So and I'm going to use some CHEM whites to dry it. So let me go dump this out. And then I'm going to use these CHEM wipes to kind of help dry out the inside of the flask. So I'll put one in there and just sort of move it around a little bit. And because it evaporates pretty quickly, I can also warm it with my hands, just like this, and the warmth of my hands will warm the acetone and help it evaporate more quickly. So I'm going to get this nice, clean, and dry, and then we'll measure the mass. Now we're measuring the mass of the dry, clean flask with the top on it. Oops, so my balance is tared to 0, so I'm going to put this in. And oops, there we go. This is the mass you should use. The next step is to fill the flask with water and completely dry the outside. So the only additional mass we're going to measure is inside. So I'm going to fill this with deionized water, and I'm going to overfill it a little bit. The big thing is I don't want any bubbles inside, so by overfilling it, and then when I get some excess out, I'm going to take and dry off the outside of the flask. and we want to take a look at it. And I don't know if you can see very well, but there's no bubbles inside the container. It's completely filled with water, and I've dried it. We need to measure the mass of the filled flask now, so the balance is tiered, and I put this in. And it seems to settle. That seems to be a good mass. The density of water changes slightly with temperature, so we need to know the temperature of the water in order to know how much or what the density is. So I'm going to measure it here for you. It's hard to focus on the thermometer, so let me read it to you. I'm just letting it equilibrate for a second. And the temperature seems to have stabilized at 19.2 degrees Celsius. In the next section, we're going to try to measure the density of an irregular solid, and I've emptied out the water and from the flask and dried it with acetone, so it should be dry and clean on the inside. Our unknown is the unknown number for this regular solid is shown right here. Whoops. And then we're just going to put these little pieces. They're little pieces of metal. They feel pretty dense. So now we need to go put the top on and go measure the mass. We're measuring the mass of the irregular solid in the flask without any water added. So we've got the balance tiered. It's at 0. That's what tiered means. So I'm going to put this in, close the door, and there you can hopefully see the mass. It varies a little bit, but that looks good. At this step, we have to fill up the flask with the unknown irregular solid with water, and then wait again. So I'm going to put in the water. Again, I'm filling it about halfway up into the neck where the ground glass, maybe a little bit more. And one thing, I got a couple little bubbles. I want to make sure I get rid of those. Let me put the top on, and now I'm just going to dry this all off, and then we'll go weigh it. Measuring the unknown irregular shaped solid in the flask and filled with water. I got the balance is tiered. I'm going to put it on. As I was drying it off, I noticed there was some bubbles inside the container, so I had to fill it up with some more water and dry it again. But there we go. We got a nice measurement. So in this last part, we have in here is an unknown solution. Right now I don't have the unknown number, but that will be posted in the Canvas site, so you know. But this is an unknown solution. It's clear, colorless, looks a lot like water, but it is not water. So we want to try to figure out what the density is. Density isn't a lot different than water, but it is a little bit. So I'm going to fill up the flask into the neck. about halfway into the neck. There. Then I'm going to put this in, and it's going to dribble off. I don't know if you can tell, but it's kind of wet on the outside, so I have to dry it off. And again, we want to check to make sure there's no bubbles in there. The problem with bubbles is that we're working under the assumption that all the inside of the flask is containing this unknown solution, which has a certain density. If air's in there, that has a different density, and so it'll lower the measured density. So we're going to get it all clean, and I'm sorry if I can't get it to focus very well, but I don't see any bubbles right now, so I think we're good. So making the final mass measurement of the unknown liquid in the completely filling our flask, and the measurement was the balance was tiered, and now we get a final measurement.